Hey everyone, this is my capstone inquiry assignment. So activity overview. The students are given a scenario to identify different metals by their properties. Students fill out a chart, answer questions related to their metacognition. It provides them opportunities to reflect on their own work and engage with larger ideas about the content and wrestle with previously held ideas about the subject. The students are also provided the question, but are given the freedom to decide how they solve the problem and then communicate their results. So here's a picture of the handout that I made and filled in as I was going along and doing my activity. So we had 5 different materials for the students to go through. High-speed steel, which is like tool steel, so when you think of what's made of like a chisel or something like that, if you see a cutting implement that looks like steel, it's actually high-speed steel. Aluminum, brass, regular mild steel, when the building component, that's what when someone says steel, it's usually mild steel, and then copper. And then on the right, you can see the questions that I had them ask. Elaborate on your methods for solving, or your methods for investigating material properties, and were they all successful? If you could redo anything, what would you do, and what do you feel you've learned? And then what understandings of materials did you have before this activity, and how have they now changed? So alignment to STEM practices. This activity aligns with STEM practices in the following ways. It engages students' preconceptions, and it builds knowledge within a framework and addresses the metacognitive processes. That's pretty much the third sheet, the open-ended questions. And I aligned that specifically with how students learn from Donovan and Bransford. It integrates and coordinates the content areas together, not as separate silos of learning. So the different processes by which you eliminate what it could or couldn't be, they're all involved with science. I mean, obviously we're doing basically a material science process. So there's a lot of science as to why and how each material is what it is. So you're explaining those. Technology, because you're using technology to test these machines, or test these materials. Engineering, because you're coming up with ways to test them, not just coming up with the different methods by which you test them. And then math, things like measuring, things like weighing, things like that. There's where your math component comes in. And we don't rely on a recipe experiment for this or lockstep methods. It uses an authentic inquiry process to introduce and develop methods by which people do science or technology. So we're not saying, okay, now take this and stick it in here and you'll get an answer. So that's how I align with STEM practices. The students are coming up with them on their own, which would be more akin to what a material scientist would be doing to investigate the properties of a material that they're working with. How they align with tenets of inquiry. So this was designed as a guided inquiry assignment. So I give them the question or the problem, and then they figure out how they want to solve the problem or the procedures for going through that process, the inquiry process. So that's a guided inquiry. That's level 3 in the Banshee and Bell Many Levels of Inquiry article. They're presented, like I said, with the inquiry opportunity, and then they have no parameters to solve it. They come up with that on their own. It allows students to collect evidence, compare it to other materials and resources like a textbook or online, and come to a conclusion through critical thinking and logic, and then state that conclusion, aligning with the NSTA position on scientific inquiry 2004. Completion of activity, here's weighing and polishing that I did. It really didn't show me that much, so if I was going to do it again, I wouldn't do that. Here's grinding, so high-speed steel on the left, mild steel on the right. They have a different spark pattern, so that's one way you can tell what it is. Cutting, which one was easier, which one was more difficult. That's a tell for aluminum versus steel, the color too. And then completion of the activity, you can see I finished the chart and did the observable properties and how I came to my conclusions, and then I answered my questions and analyzing my processes. So thank you all for a very great class. The discussion was excellent, and I hope you all do well in this class and going forward. Thank you.